Hi, my name is Caitlin, and today I'm going to be talking about exception handling in C++. This is what I want to touch on today: what exceptions are and when to use them, using try, catch, and throw, process, uncaught, and unexpected exceptions, declaring new exception classes, how to handle failures, and how to understand the standard exceptions. First, let's learn about the intro to exceptions. Exceptions show problems that occur during a program's execution, and they rarely occur. Exception handling can resolve exceptions. They allow a program to continue executing or notify the user of the problem and terminate the program in a controlled manner. More on exception handling. This is a standard mechanism for processing errors. It is especially important when working on a project with a large team of programmers. Now, let's talk about the class exception, the standard C++ base class of all exceptions. This provides derived classes with virtual function what returns the exception stored error message. Next is the try exception. The keyword is try and is followed by braces. It should enclose statements that might cause exceptions, statements that might be skipped in case of an exception. Next are catch handlers. These immediately follow the try block. One or more catch handlers for each try block. The keyword is catch, and they are enclosed in parentheses. Inside the parentheses should be what represents the type of exception to process and can provide an optional parameter name to interact with the caught exception object, and executes if exception parameter type matches the exception thrown in the try block. Could be a base class of the thrown exceptions class. Now let's talk about programming errors. A syntax error to place code between a try block and its corresponding catch handlers. Each catch handler cannot have only a single parameter. Specifying a comma-separated list of exception parameters is a syntax error. A logical error to catch the same type in two different catch handlers following a single try block. Next is throwing exceptions. The keyword is throw, and it is followed by an operand representing the type of exception. The throw operand can be of any type. If the throw operand is an object, it is called an exception object. The throw operand initializes the exception parameter in the matching catch handler, if one is found. Catching an exception object by reference eliminates the overhead of copying the object that represents the thrown exception. Associating each type of runtime error with an appropriately named exception object improves the program's clarity. Now, when to use exception handling. You would use it to process synchronous errors, and this occurs when a statement executes. Not to process asynchronous errors, occur in parallel with and independent of program execution, to process problems arising in predefined software elements, such as predefined function and classes. Error handling can be performed by the program code and to be customized based on the application's needs. Now let's talk about constructors and destructors. First, exceptions and constructors. Exceptions enable constructors to report errors, but they are unable to return values. Exceptions thrown by constructors cause any already constructed component objects to call their destructors. Only those objects that have already been constructed will be destructed. Now, exceptions and destructors. Destructors are called for all automatic objects in the terminated try block when an exception is thrown. Acquired resources can be placed in local objects to automatically release the resources when an exception occurs. The benefits of using exceptions are, with exception handling, a program can continue executing rather than terminating after dealing with a problem, helps to support applications that contribute to mission-critical computing or business-critical computing. And when no exceptions occur, there is no performance penalty. In conclusion, exceptions are derived from class exception. Exception or error condition is indicated by throwing an object of that class created by constructor in throw statement. Calling programs can check for exceptions with try and catch construct. Unified method of handling exceptions. Far superior to coding exceptions handling in longhand, and there's no performance impact when there are no exceptions. This concludes what I had to talk about exceptions, and I hope it taught you a little bit about the basics of how to use them in your code.